chi-square goodness of fit test is a non-parametric test that is used to find out how the observed value of a given phenomena is significantly different from the expected value. In chi-square goodness of fit test, the term goodness of fit is used to compare the observed sample distribution with the expected probability distribution. To further understand this, let's take a look at an example to start. Belle, the store owner who sells ice cream, wants to stock ice cream that were bought more frequently because of its flavor. The 5 flavors were vanilla, chocolate, strawberry, Rocky Road, and cookies and cream. According to Belle, the expected number of customers should follow the percentage of last year. She thinks that 25% would choose vanilla, 20% would choose chocolate, 15% would choose strawberry, 15% would choose Rocky Road, and 25% would choose cookies and cream. She conducted a survey and took a random sample of 300 customers. She asked them their flavor preference. But first, here are the steps to compute for the chi-square goodness of fit test. So here's our table for our data. We computed the expected value through multiplying our sample size, which is 300, with the percentage of each flavor. The PI symbol stands for percentage in this table. Here is our calculated expected frequency. So in our first step, we will state our hypothesis. Our null hypothesis is there is no significant difference between the customer's flavor preference from last year's data. While our alternative hypothesis is there is a significant difference between the customer's flavor preference from last year's data. Our second step is to calculate the degrees of freedom. Degrees of freedom is equal to the number of levels of the categorical variable minus 1. So our number of levels is 5. It pertains to the 5 different flavors of ice cream. So if we subtract it from 1, our degrees of freedom will be 4. Our third step is to calculate for the test statistic. The formula for this is x squared equals the summation of O minus E squared divided by E, where O is the observed frequency count and E is the expected frequency count. Here is our solution for our example. So in the first parenthesis, which is the data from the flavor vanilla, we subtracted the observed, which is 73 and 75, then square it. The answer is divided into 75, which is the expected count. Then we will calculate the answers from each flavors and add those. The final answer will be our test statistic, which is 14.48. Our fourth step is to state the decision rule. Our alpha or significance level is 0.05 or 5%. We have this chi-square table where we look for alpha 0.05 with 4 degrees of freedom. Now we find 9.48773. So we say if our p-value is greater than the table value, which is 9.48, we reject the null hypothesis. In the fifth step, we will state the results and conclusion. So since the computed test statistic is greater than the critical value, we reject the null hypothesis. Therefore, there is a significant difference between the customer's flavor preference from last year's data. In here, we are going to show you the procedures and interpretations of chi-square goodness of fit test using SPSS. The following is a sample of the number of individuals who called in on the different days during their work last year. The first step is to enter the data. We will be needing 2 columns, one for day and one for call-ins. The second step is to click data and then wait cases. Then there will be a window that will pop up. Select wait cases by, then move the call-ins variable over to the frequency variable and then select OK. The fourth step is to select analyze, then non-parametric test, and then one sample. Select the Fields tab and ensure that day is in the Test Fields box. Select Settings and then select Choose Test. Choose Compare Observed Probabilities to hypothesize and click on the Options box. Click on the All categories have equal probability and then select OK. The output window will populate the test results. The test statistic is 6.662 with a p-value of 0.155. Since the p-value is greater than the level of significance, which is 0.05, we will reject the null hypothesis. In conclusion, there is a significant difference between the number of call-ins on the different days of the week. To elaborate this more, here are the different informations that you need to remember to perform chi-square goodness of fit test. Once again, chi-square goodness of fit test is a non-parametric test that is used to find out how the observed value of a given phenomena is significantly different from the expected value. It is used to compare the observed sample distribution with the expected probability distribution. To make sure that the data that we want to analyze can actually be analyzed using chi-square goodness of fit test, the data should meet these 4 assumptions. First assumption, the data should be one categorical variable. It can be dichotomous, nominal, or ordinal. Examples of dichotomous include gender, treatment type, educational level, or if a person is religious or not. Examples of nominal variables include ethnicity and profession. And the examples of ordinal variables include Likert scales, amongst other ways of ranking categories like scale for measuring job satisfaction, a 4-point scale determining how easy it was to navigate a new website, and physical activity level. For the second assumption, you should have independence of observations, which means that there is no relationship between any of the cases. The third assumption is the groups of the categorical variable must be mutually exclusive. For example, if the 4 groups of a categorical variable physical activity level were sedentary, low, moderate, and high, a case could only be in one of these 4 groups. Lastly, the fourth assumption is there must be at least 5 expected frequencies in each group of your categorical variable. This is an assumption of the chi-square goodness of fit test and will be shown in your SPSS statistics output when you run the test. If these 4 assumptions are met, then here are the procedures for chi-square goodness of fit test. In setting up the hypothesis, your null hypothesis should assume that there is no significant difference between the observed and the expected value, while your alternative hypothesis should assume that there is a significant difference between the observed and the expected value. The next procedure is degrees of freedom. The degree of freedom depends on the distribution of the sample. To calculate the degrees of freedom, we just need to take how many groups we have in our data and then subtract 1 from it. Just like in our first example, the number of groups that I am pertaining is the 5 different flavors of ice cream. Then we subtracted 1 from it and our degrees of freedom is 4. Lastly, in hypothesis testing, it is also the same as in the other tests. The calculated value of chi-square goodness of fit test is compared with the table value. If the calculated value of chi-square goodness of fit test is greater than the table value, we will reject the null hypothesis and conclude that there is a significant difference between the observed and expected frequency. Then, if the calculated value of chi-square goodness of fit test is less than the table value, we will accept the null hypothesis and conclude that there is no significant difference between the observed and expected value. These are the references that we used for the contents of our video. Here ends our discussion. Thank you for listening and God bless.